Okay, so it's lesson 2, part 1. Today is September 15th. It's the fall semester at Georgian College. This is our JavaScript frameworks Tuesday section. So what are we going to do today? We're going to do a little bit of review of some of the stuff we looked at last week in our overview of the mean stack. We're going to spend probably the first part of today looking at closure structures. So we actually used closures last week, but I didn't really talk about what they were. So we're going to spend some time kind of doing a bit of a deeper dive in understanding what a closure is and why we use them. So my goal at the end of that first hour of class is you walk out of here, and if in a job interview, somebody asks you to tell them what a closure is and why we would use it. Yes, sorry, it is. I said Wednesday. I said Tuesday. It is Wednesday. Yes, my apologies. That you understand what a closure is and why we would use them. Then the latter part of class, we're going to start playing around with NPM. We just touched on NPM really briefly last week, but we're actually going to start integrating it into our application and seeing how NPM works. So I'm actually just going to open up the files we worked on last week. So I'm going to open up WebStorm. It's actually just opening up the files we had from last week. I'm not going to worry about doing a software update right now. I'm probably just going to work in this same project for today. But what I'm interested in is our non-blocking JS file we did last week. So there's some syntax here that's, I'm going to see, I might change my color theme. Can you see is the theme working well? Or would you prefer if I switch to a white background? Would that be easier for you to see the code? I can see it okay, but I'm not sure everybody can see my screen that well with the dark background. Looks good. Okay, all right. So long as it's working for you guys, okay. Raymond, you like it? All right, we're good then. So a lot of this is just plain JavaScript. No, Chris, by all means, fill your boots with VS Code if you like. So there's this is fairly standard JavaScript, except there's a little bit of syntax that was new or unfamiliar. What do you see in here that maybe you saw for the first time in our class last week that you hadn't seen before? Okay, so you hadn't seen require before. Okay, yep. So for including a dependency or a third-party library, yep. What about in the blocks from lines 5 to 7, particularly line 5 and line 11? Okay, Artem, so one is, yeah, we're using the lambda expression instead of the keyword function. Yeah, Adam said you hadn't seen the file system object. Yep. Booger mentions that the error parameter is new. That's true. Morning, Milo. There's one other syntax construct on line 5 and on line 11 that you may have not seen before. So you've mentioned a bunch of things. In particular, I'm thinking of the variable use. What's unusual about how we used variables on line 5 and on line 11 that we probably did for the first time last week? Okay, so Adam meant we don't call them after initializing them. True. And Chris, okay, so we have the callback structure. Yes. So we've got one function being passed as a parameter to a second function. That's true. But there's also something particular to the variables that we used and how we used them on lines 5 and 7. So on line 5, we created a variable called food, but then in the inner parameter function, notice we've used the same variable name again. So this seems kind of odd that we've used the same variable in two different ways. Jillian, that's a good guess. It's could be thought of as overloading, but it's a little bit different because overloading typically is with methods. It's not, it sort of can be related, and we'll come back to it. So that's actually an interesting way of thinking about it. I hadn't thought about it before. And then same here on line 11, we've declared a drinks variable, we've set it equal to the result of a function, but then in the callback, we're actually using the same variable name. So this particular structure, we're going to see it all the time in JavaScript. And this particular, anybody know what this particular function, what this particular structure is called? Okay, Adam, this part is the anonymous function, yes. But the structure of assigning a variable and then using that same variable inside the nested function. Jillian, you're getting warmer. It's related to the scope. You guys are very close. What this structure is called, and I've got a link here up on Blackboard, nobody's quite mentioned it yet. It's actually called a closure. So there's a link here on Blackboard in lesson 2. You can open it up. So this is an article on Medium. You may have to sign in with a social media account to access it. So this tutorial is really describing this closure structure. So at a simple level, yes, somebody mentioned, Chris mentioned, Adam mentioned recursion. So it's like a style of recursion, sort of a function within a function, but there's a more important feature to it. And I'm not going to read the whole article, but we're going to kind of look at parts of it, and we're actually going to try some of the examples in here. So, and as Douglas Crockford mentioned, and Douglas Crockford is the developer who actually created JavaScript object notation, that, yeah, we can write JavaScript without doing closures, but it's kind of like creating Java code without understanding or using classes. The closures are kind of a key to modern JavaScript programming. So we're going to go through some of the examples, and the idea of closures is that they're all around managing variable scope, which I think somebody mentioned. Yeah, so Jillian, you mentioned scope. And it's really important in JavaScript that we use this closure structure to effectively manage memory and performance and control scope of our variables. Okay? And this is also part of the key to how Node runs our code asynchronously. So the simplest definition of what is a closure is a function that refers to variables from the parent environment. Okay, so if we look at our code here, we're using the food variable in our inner function, but it actually refers to this variable from the parent. That may seem confusing, but we're going to do a few really simple examples so that this becomes more clear. So this means variables we declare in a parent function are bound inside the closure. or that nested or child function. So we're going to play around with a few examples where we've got some nested functions, and we'll look at how this all works and why it's so important. So I'm going to go ahead and make a new JavaScript file. And I'm going to call this one open function. So we're going to write a JavaScript function that contains another function inside but doesn't use a closure. So first, probably the best way to illustrate how a closure works is first try an example without a closure, and then we can rewrite it using a closure. Much like how last week we wrote a non-blocking file first and then a non-blocking file. Booger, that's just a warning. Yeah, it's a warning from my code editor. Correct. If you remove that, we don't assign the variable to it, it should remove it. Yes. Because we're assigning it. Good question. Okay. So we'll create a parent or wrapper function that contains a variable. So I'll create a simple function called parent. And we'll create a variable called message. Actually, we'll say this, hello from parent. And now we're going to put another function inside of this. So we're going to log out the message variable. So if we want to and in here, execute function. So if we want this code to run, what would we need to do on line 14? So we've got a parent function, we've got a variable declared and assigned, and then a child function that's going to try to access and display the parent variable. Okay, so Booger says we can just call parent. Okay. So before I run this, what do you think the result is going to be when I run this in my terminal? There's three options. It could print out hello from parent. It could print nothing. Or I could get an undefined error. What's your prediction before you run the code? What do you expect the result will be? Is it going to print hello from parent? It's going to print nothing, or are we going to get an error? Okay. Think it will return an undefined? You think Booger and Chris say it will say hello from parent? Any other predictions? What do you think? You think it will print a message? Okay. So I'm going to open up my terminal. If I try node and run the file, Fatima says nothing. Let's see what happens. So in this case, it prints the message. So what does that tell you about the scope of our message variable? What does this suggest if we declare it and populate it inside the parent function, but the child or nested function is still able to access the variable? Yeah, so in JavaScript, variables are scoped. They'll be scoped to that top level function where it's declared, but anything that's inside also has access to it. So any variable declared in parent is bound to this closure structure. Anything nested inside can access it. Now, what happens if we do this? What will the result be if we run it now? Okay, Booger thinks it will say hello from child. Okay. So I'll just hit my up arrow in my terminal to repeat my last command. And yep, your predictions are right. It'll say hello from child. So if we have two variables from the same name, the most local scope is always going to take precedence. We could even try this. I'll say hello from global. So I've got three instances of the message variable. One at a global scope, one at the parent scope, and one at the child scope. What will display if I run the code this time? Yeah, Adam says going to be child again. Yep. So it's still going to take the most local scope, the narrowest scope possible, right? Yep, so all your predictions were right. Okay, I'm going to take that back out. That was just for demonstration purposes. So I'm going to remove those. So we can see how this function, this closure, it encloses this variable, so this variable is available anywhere inside that set of curly braces. So we're going to try a couple other examples that I've adapted from this article. Okay, they've given some other examples. We're going to try them. So I'm going to make a new JavaScript file. And I will call it I'm going to call it closed function. Let's see, how do we want to do this? We're going to rewrite this one a little bit of a different way. We'll create our parent function. We'll set up our message again. hello from parent. Then we'll set up our child function. And we'll log it out. But this time, instead of calling the function here with child, instead of executing it, we're going to return it. So we're sending back a reference to the child function. So this time, instead of executing parent directly, we're going to assign a variable to represent the parent function, but not execute it yet. And now execute. So this code is, these two pages are functionally equivalent, except here we are executing the function all at once. Here we're making a reference to that function, and we do this in Node all the time. We make a reference, we assign a function to a variable, and then we can execute the function separately. If I run it, we get the same result. So these examples may be a little bit contrived, but our idea here is this allows us to take a function, assign it to a variable, and then we might pass this variable to another function as a callback. So every time an event, for example, gets emitted in a Node application, we can invoke a function. So what does this have to do with variables exactly? That part isn't clear. One thing to keep in mind is the memory management with variables. Every time we call a function, any variables declared in that function have to be created in memory. So memory allocates every time we call a function. So we'll have many instances where we need to call the same function repeatedly. Can you think of any examples in a web application? What would be a process where we might have a function and we're going to call it many times? What would be a use case for that? Okay, yeah, we want to update a timer. Okay, that's a great example, Chris. Yeah, we're checking for changes in something. So we're going to run that function over and over again. When else? What other kinds of functions might be called repeatedly? Yeah, updating a feed. Yeah, okay, Booker. So what would be an example? Think about it in terms of a web application. When might you use a recursive function? What would be a business case? And Simon, yes, for a request, but I'm asking you to be a bit more specific. Like, give me an example of a request that might need to run repeatedly. Okay, refreshing a page. Yep, that could be something like a stock ticker. Yep. Right, live updates, checking a clock. These are all excellent examples where we're going to have a function that we want to call many times, repeatedly. So in this case, if we have to call a function repeatedly, there's a performance cost if that function has to create has to instantiate and populate variables. So it's going to be much more efficient if we know this function needs to run many times. When we use this closure, if we declare the variable and then we have this closure structure, we can create those variables once. And then we can run our repetitive process inside as a child or nested function. I'll give you another common example. Let's say we're sending out an email. We're sending out a list of emails, and maybe that email has some general text, like some introductory text, that's going to be the same for everybody. Like maybe we've got people coming to an event and we want to send them a reminder. So right now the reminder might be, make sure you have your bring a mask and that you have proof of vaccination before you can attend the event. But then inside, we also want to send some content that's personal. Like we want to include people's emails somewhere in the message, and maybe include their ticket number or their seats. So the introduction text, we only want to create that variable once. If we have to send out 10,000 emails, we don't want to create, populate, and then destroy that introductory message 10,000 times. We want to create that part once, and then we'll need to create the individualized content each time over and over again. So with this closure structure, this will allow us to create that the shared content one time and then individualize the other content in a much more memory efficient way. Does that make sense in this context? Another example might be, let's say we're building a shopping cart, and on the cart page, right, we need to loop through and we need to repeatedly fetch the items from the user's cart and display them on the page. But we also want to have a running total. So we can instantiate that total variable once, initialize it to 0, and then as we're querying the database and outputting all the cart items in a loop, we can just refer to that total and increment it. We don't have to keep recreating that total variable. And we want the value to persist. Each time we put a new item in the total, we don't want to initialize our total to 0. We want to add on to the existing value. Closures also let us share variables, but they also let us avoid global variables. And global variables are not advised at all in JavaScript. Can anybody think of any reasons why we would want to avoid global variables as much as possible? Yep, security is one. Why else? What are some of the other reasons to avoid global variables whenever possible? Okay, that's a good one, Adam, right? The longer the variable exists, so if we're writing a page in JavaScript, if we declare that variable at the top, the variable is going to persist for the entire life cycle of the page, so it uses up memory. Yep. Can you think any other reasons why we may want to avoid global variables when we can? What about testing or debugging? Why is it easier to work with local variables? Yep, they can lead to errors. True. If you're trying to debug code, unit testing becomes difficult with global variables because it makes it much harder. If we declared this message globally, well, how do we unit test this function on its own? So global variables make unit testing and they make debugging difficult because a variable can change many, many times as it gets passed from function to function to function. So for all these reasons, we should try to avoid global variables. So closures allow us to do this. They allow us to keep a variable only for so long as we need it with this structure. Let's try a couple other simple examples. I'm going to make a new JavaScript file, and I'll call this one open counter. So we're going to use a function with a counter variable, and we'll do an example again, first without a closure, with an open function, and then with a closure. Open. So a non-closure function or a counter. So I'll call this open function. I'm going to use var instead of let because our variable is going to change. So every time this function gets called, we're going to increment the counter and we're going to log it. Then we want to run the function twice. So I'll call open function. So when we run this, what result do you expect we're going to get? Okay, Chris says 1 and 2. Adam says 1 and 2. Chris says 1 and 2. Try it out. Whoops, sorry. This is open counter. Oh, what happened? Why did we get 1 and 1? Right, we're running the same program twice, and as Cameron said, each time this function gets executed, what's the first thing that happens? Okay, it wants me to use let. I guess I could use let. So the very first thing that happens is it initializes to 0. And then we add 1, and then we log it out. So with the open function, there's no ability to persist that value. And this isn't great for our memory allocation because every time the function gets called, we're recreating this variable as well as initializing it to 0. So we want to try running this time with a closure. So I'm going to make a new file and we'll rewrite this, but use a closure structure. That's right, Booger. If we declared this up here, which again, we've said before, generally not great practice to use global variables. Whoops. So yeah, if I ran it now, yeah, now we'd get 1 and 2, but now we've kind of violated the best practice around global variables. So we want the variable scoped to the function. We don't want it global. So now let's make a closure counter. I will put all these files up on Git when we take a break. But now we're going to use a closure as a wrapper. So the variable only gets created once in memory. So what did I call it? Before it was open function. So again, we're going to initialize counter to 0. Now we're going to use a second variable and assign it to a child function. So I'm going to create a variable called increment, and I'm going to assign it to, this time it can be an anonymous function. So I can even do it this way. I can use this lambda expression. And now we're going to increment and print out the value in here. And then we'll return the variable. So now we're using a closure. This variable should only be created once. And we're using our nested function and our lambda expression to actually do the work. So with our open function, I just go back for a moment. Remember, creating the function and running it happened at the same time. So it happened twice. This variable was created and instantiated on each call. So we're going to assign a variable to the closure function. But it doesn't execute right away. So we're going to assign a variable to the function. And then we're going to execute it twice. So in this instance, we should get a different result. Our variable should only get instantiated one time. Let's try it. So notice now we get 1 and 2. So the variable gets created and set to 0 here. And when we actually execute it, the value of counter persists each time. So we can use it like a global variable, but it's still only available within the scope of our function. Wouldn't be available to other functions. So not only is this good for memory management, it's good for performance, and it allows us to closely control the scope of the life cycle of a variable. So we can create it once, and then we can use that variable in repeat processes, but still keep the scope of it private to that whole set of control structures, not available anywhere else. So we've used a combination of some of the syntax items we talked about at the beginning of class. Okay, Booger, what if we call the function without assigning it to a variable? Great question. Let's try that. So in this case, you just want to call closure function twice, right? What will happen in this case? Booger, I'll let you predict what will happen. Are we going to get 1 and 1? Or are we going to get 1 and 2? Okay, so we don't actually get anything. How come if we just try and execute the function twice, and Adam, I'll come to your question in a moment. So if we just try calling the function directly, notice there's no output at all. How come? Okay, Adam and Chris, that's right. Because there are no other functions besides the return value of the child, right? It's never assigned to a variable. So as Chris said, we do need, when we're using this structure, we need to assign a variable to it. Yes, Adam, when we're using the closures, we just need to call the parent once to initialize things. Okay. Yes, that's correct, Adam. I would recommend, so here, let's have a look at how this works. So I've adapted some of the examples from this article. It's well worth reading. So when the function gets called, memory gets allocated, and memory gets allocated here. We do our processing, and when the function is over, the variable is released. Okay, so there's no closure here. But when you wrap a function, it creates this scope, sort of fence around your code that says to JavaScript, hey, when the function's over, don't destroy the variables yet. So I've adapted, and there's a bit more explanation here. So the scope here is enclosed in the parent. It's wrapped. So assigning it to a variable instantiates an instance of the function, and each instance lets us track the memory. But then this is what actually executes the function here. So instantiating and executing are separate processes. But yes, Adam, we only have to do the instantiation once. So this might be another simple way of thinking about it. A closure is a function that preserves data. When you create a closure, you're telling JavaScript to remember the variables inside the functions. So there's a few other examples here. It's not just putting a function inside another function. Yes, we typically are nesting functions, but it's a technique from preventing variables from being changed and isolating them within a particular section of your application. And we're going to use this structure all the time when we're working with Node. This is the nature of Node's asynchronous model. So if we come back to our non-blocking, The food variable, it really only persists. There's the scope. We can log it out inside of the closure. It exists. So it's important that we have a look at this syntax because it is quite different. We haven't done this before. You haven't used this kind of structure with Java or C# or PHP or any of the other languages or frameworks that we've worked with so far in the program. I will push this code up to GitHub. So these are our closure examples. So I do really recommend you have a read over this article. We've gone over a lot of it, but the link is right here for you. Does anybody have any questions about any of these files or anything else to do with closures? Okay. So what I think we will do, I've pushed this code up so you can check your code with what's on GitHub. And let's take a break here. And when we come back, we're going to take a bit of a more detailed look at NPM, and then we're going to try using NPM in our application. So we will come back at 12 to do that.